How do VISCOPLEX pour-point depressants improve cold temperature performance? Let's use engine oil in cold temperatures as an example. At startup with the oil cold, maintaining pumpability is critical. Let's compare, in contrast, engine oil without VISCOPLEX PPDs and engine oil that has been treated with VISCOPLEX PPDs. When oil temperature is at the cloud point or below, wax crystals appear. As the temperature continues to drop, without the additional PPD, the wax crystals conglomerate more rapidly and become much larger, as demonstrated in the view on the left. The viscosity of the untreated oil is increasing rapidly, with the appearance of structured wax crystals. Notice the large wax crystal network that has formed in the absence of VISCOPLEX PPDs. Compare them with the smaller crystals in the PPD-treated oil on the right. As the temperature continues to decrease, especially at a slow cooling rate, bigger wax crystals in the untreated oil are trapping oil within their network structures, and this ultimately leads to a phenomenon known as yield stress. On the right, in the treated oil, VISCOPLEX PPDs co-crystallize along with the wax molecules present in the oil, limiting the size of the wax crystals and maintaining adequate oil fluidity. Let's have a closer look through the microscope. Once an oil has reached its cloud point, wax molecules first form needle-like crystals, then grow into plate-shaped structures. And if temperature is decreased sufficiently, the plates will further develop to form a gel-like network structure. The oil ceases to flow in this gel-like state, and viscosity increases significantly. These simulated views explain the wax gelation process at or below the cloud point. Cloud point is the temperature at which wax begins to crystallize due to the beginning of the conglomeration of the large wax crystals. Let's magnify further. How does the VISCOPLEX PPD modify the crystal size and shape? When temperature is above the PPD melting point and above the wax cloud point, the oil appears clear. As the temperature drops below the cloud point, in the view on the left, wax molecules solidify in the untreated oil. But in the view of the treated oil on the right, there are not only wax molecules, but also a PPD polymer backbone with a distribution of branching, waxy side chains. As the temperature continues to drop in the view on the left, wax crystals are formed from the wax molecules in the untreated oil. In contrast, in the view on the right, wax molecules co-crystallize with the waxy branches on the polymer backbone in the treated oil. In this way, the wax crystals are kept apart from each other by the PPD backbone. The paraffinic side chain of VISCOPLEX PPDs, identified by the yellow block structure on the right, interacts with wax molecules and mediates wax crystal growth. Optimal fluidity is achieved as the PPD composition matches with the wax characteristics of the oil and effectively disperses wax as a group of small crystals. Let's summarize. As temperature drops to a level below the cloud point, the PPD in the treated oil will co-crystallize with the wax molecules. This prevents formation of needle or plate-like crystals. The nucleation of the combined PPD wax crystal structure leads to the formation of smaller and more random wax crystal structures. The result? No aggregation of a gel-like wax network, and oil continues to flow and to pump without yield stress. Careful selection of the proper PPD and optimal dosage are the key factors in achieving the desired cold temperature performance. With the oil additive specialists at Evonik as a partner, lubricant marketers can count on a customized solution to their low-temperature challenges, as well as expert guidance and support.
Evonik. Power to create.